really what types of insurance there are, an overview of the industry, and then I'll touch on reinsurance is and how reinsurance fits into that, because it's a kind of interesting subset of the insurance industry that not a lot of people are, I guess, aware of. And then I'll talk about the specific team that I work on, so the North American Integrated Analytics team, really what that team does, our mandate, the different types of projects we do. Then I'll talk about our structure, different types of roles, and the skill sets that kind of go into those roles. Finally, I'll delve into the problem space that we work in, right? So I'll talk a little bit about the types of problems that we're seeing within insurance, how we use data science and analytics to handle those, and then how that's sort of evolved over time, as well as some other sort of interesting tidbits about the job. Then I'll end off probably on just the tech stack, so talking through some of the tools that we use, and then I think we'll take probably a short break after that. And then after we take the break, we can go through a case study. And so we'll be looking at building a mortality model for group life insurance. And so essentially predicting likelihood of death in the context of group life insurance, which is a specific type of life insurance. So I will pause intermittently, I think, for questions. We'll probably hold them until the end of certain sections. But yeah, just like a general, I guess, housekeeping item. I guess just to start off, so who am I? So my background's actually in physics, interestingly. So not in computer science or some of the other, I guess, more common data science fields. So I actually studied physics at McGill. When I was a student at McGill, I did an internship actually in reinsurance, which is the industry I now work in. That was more actuarially focused. And I did a bit of research there looking at astrophysics, which is where I kind of got my start in the data science realm, learning about data analysis and really touching on it there. After graduating, my first role was at Bell. So that was data science focused really on operational improvement. And interestingly enough, it was a lot of natural language processing. Back when I joined, which was 2018, NLP was a lot different than it is today. So now we have large language models. Things have really taken off and are a lot more advanced. Back then. We're using much simpler, still deep learning models, but much simpler, more rudimentary techniques for natural language processing. But a lot of my first role was really trying to use machine learning to automate certain processes and decision-making areas, and then using NLP really to extract a lot of information that at the company we had in free text form that wasn't really leverageable. A few years in that role, I found that I was looking for a different sort of subject area to work in. So I wanted to go back into the area that I'd interned in rather. And so I went back into the reinsurance space. So I work at a company called Munich Re now. And what Munich Re does is we offer reinsurance to the industry. One level sentence of what reinsurance is, essentially reinsurance is insuring insurance companies. So it's one additional layer of risk management. And really the team that I'm on within the reinsurance company serves a few purposes, but we're focused around the whole broad concept of risk assessment. And so predominantly what that means is leveraging different data sources and tools to assess mortality risk, right? The chances of individuals dying, because we do work on the life and health side and disability as well. But then also there's risks related to that as well that aren't directly mortality related. So understanding just general health and wellness, morbidity risk, things of that nature. I would say the predominant focus of our team data science within the life reinsurance space is around risk assessment. And I'll get into more of what that means shortly. I guess some interesting tidbits there as well are because we are a reinsurance company, our clients are insurance companies. And so predominantly the work we do is not just internally facing, we do a lot of work for the insurance companies that are our partners. And so not just helping to better risk assessment that we do, but helping to better risk assessment that the companies we work with do as well. And then just some interesting or not so interesting facts about me. So I'm a father to a 6-year-old. I do a lot of running. I read a lot of really dry books. I used to be a competitive taekwondo and kickboxer. Now I just do things like pickleball, play squash. Not as exciting, but try to stay active there. And my 6-year-old keeps me very busy. So here we'll just kind of talk through, just to get an understanding of the space that I work in, what insurance is. So here I have the Webster's definition. So insurance is a coverage by contract whereby one party undertakes to indemnify or guarantee another against loss by specified contingency or peril. Really what this is, you can think of insurance broadly as a contract to cover a risk, right? So when you think about insurance, there's a risk of some adverse event happening, whether that be death, disability, a car accident, a flood. There's some risk that you want to cover, and the insurance company provides you a contract, which will, in the event of this unfortunate event, provide some sort of coverage to ease the financial liability or whatever other liability you might have. And really, you can think of insurance, very broadly speaking, as being divided into two large areas. So I have these kind of outlined on the right here. You can think of these as being long-term and short-term, right? So long-term insurance is the field that I work in, and that's predominantly things like life insurance, disability insurance. These are, you think of as long tail risks, right? So life insurance is, you have a life insurance policy. This is something that can cover you 5, 10, 20 years, and it's a risk over a long period of time. And interestingly as well, these are risks that you typically only assess once, right? So if somebody were to buy life insurance, they typically get underwritten or risk assessed, you could say, one time, and then they have that policy, and that policy covers them until either they cancel the policy, or the policy term ends, or they die, or whatever else, right? Now that's in contrast to what I have here, short-term insurances, and these are things like your home and auto. And so anybody here who drives will know, your car insurance, the rates change. Your risk is essentially reassessed every year, right? If you get into an accident 1 year, the next year your car insurance rates are going to be higher. So these are really looking at these short periods of time to assess and monitor risk. That's in stark contrast to the life side. And so what that leads to actually is to some key differences in the way the business operates, and really how data science intersects with the insurance industry. So on the short-term side, when you're looking at home and auto, because you have a much shorter period, and because you're able to reassess the risk of individuals in a very short time span, you're able to take slightly more risks and innovate slightly quicker, you could say, because you're able to both identify and remediate the mistakes you make much quicker, right? So as an example, if a property insurer, or car insurer, I should say, were to use a machine learning model to come up with prices for car insurance, they could implement that model, charge people a certain rate. In 1 year's time, they could look back and say, hey, we actually, didn't do that great of a job with that model. We charged people too little, and we took losses that were slightly higher, and they could go in and readjust and tweak that. And they're only living with essentially, 1 year's worth of mistakes because of that, right? They have the ability to both quickly, measure the impact of this new tool, and then also make changes to it. In contrast to that, you have on the life side, that's not true for either of those aspects. So within life insurance, if you were to misassess someone's risk, two things are true, right? One, because death is such a rare event, it typically takes a long time for you to understand whether or not you made a mistake in the risk assessment. So in a typical, block of insurance policies, this could be anywhere from, 3 years to 5 to 10, or sometimes 15 or 20 years before you start realizing that there was a misassessment of risk. And at that point, you're already living with 20 years of mistakes, more or less, that are going to slowly come through. And the other one is, because you only assess risk at one point in time, you can't just go back and raise people's rates, right? Typically, with life insurance, you can't go back and say, hey, we're going to charge you more, or, we don't want to cover you anymore like you could with car insurance. So there's this big incentive for life insurers to do a lot of due diligence and be very risk averse in terms of implementing or changing existing methods, right? So if you have a paradigm of risk assessment, and it does a good job, and there is now alternative approach that's being discussed, they're typically not against making those changes, but there's very often a lot of scrutiny and due diligence that comes with trying to implement something new. And that's because of really I wouldn't say grave consequence, being a bit dramatic, but because of the serious and longer term consequences that can be faced due to misassessment of risk. And so really I've talked about what insurance is. Now I work on the life side of insurance, so I typically deal with the longer term type of products, so things like life insurance predominantly, as well as things like long-term care or disability was more of a secondary focus. And really, as part of that, one of the cruxes is this aspect of risk assessment, which is also known as underwriting. And so this is really, you can think it's the core function, or one of the core functions of insurance. Individuals apply for insurance, the company assesses the risk, right? In the life context, this could be the assessment of the likelihood of this person dying, or the general rate at which they think they might die compared to the general population or another population. It could be the risk of specific disability in the context of disability insurance. It could be the risk of a long-term care home and potentially how long they'd be there. It's assessment of risks of that nature. On the car insurance side, the other side, that's shorter term risks, your odds of getting into an accident, your odds of your car being stolen, things of that nature. But really, that's really the core function of insurance. And that is a big lever in determining whether or not insurance companies are profitable or not, whether or not they're competitive as well. If you underwrite or assess risk improperly, in the sense that you undercharge people, then your future expenses, the claims you pay, are going to be higher than what you price for, and the premiums you collect, and as a result, you won't be profitable. And then on the reverse side of that, if you misassess risk too conservatively, no one's going to buy policies from you, right? A company that is very conservative in the way they assess risk and wants to charge people more than the risk that they actually present, typically those people are going to go to their competitors, right? So, really one of the big focuses within insurance is ensuring that you are, assessing risk in the most accurate way possible. Now, in the context of life insurance, typically, this is the assessment of medical risk. And so within the past, the way you would assess risk is a long and lengthy medical process that would involve the collection of not just application questions and not just questionnaire, but actually historically would involve the collection of fluids and lab tests, right? So you can think of historically, if somebody were to apply for life insurance, they'd fill an application, they would disclose the disease history that they have, different medical issues, things like BMI, height. But in addition to that, the company would want additional information to make a more robust assessment of the risk. So typically that would involve either them going to a lab provider or somebody coming to their house to collect blood, urine, other requirements. And then sometimes as well for certain types of policies that could involve even additional requirements. So one could be ordering robust medical records from a doctor, or it could involve specialized tests in the case of very expensive life insurance policies, example being treadmill tests and things to that nature. But really, the companies want to ensure they're assessing risk properly. And historically, prior to the advent of lots of data, most of this risk assessment has come through this process, right? This long, lengthy process of collecting all these medical requirements and then using those to assess risk. So, historically, this is the way things were. There weren't really any other alternatives to that. If you were to skip the process of ordering labs, then you leave yourself exposed to potential misrepresentation, right? People can just lie in an application. You have no way to actually assess their health risk, and so this is kind of just the way things were done. But more recently, there's been this big push to move away from this long, invasive, cumbersome process into something that is much more modern and streamlined, a better customer experience, and something that leverages technology, right? So here I have really just I don't have the book on me right now, but a bit more information on what underwriting is. So in the past, you'd have all those requirements, and from those, you'd collect those lab values, you'd collect fluid values, and what other medical evidence you would need to underwrite. And the actual process at one point in time was entirely manual. So somebody on the other end would have, on their desk, they'd have filled out application and lab values, right? The test from the lab that says their cholesterol is this, their A1C is this. And they would go through a big book like this. This is Medical Selection of Life Risk, which I have a physical copy of. And they would look for, specific rules related to each piece of information. So it might be something like, oh, they have diabetes that they disclose. Well, how long ago were they diagnosed? And then is there any lab value that would dictate what the level of risk is for their diabetes? What is their most recent glucose value and their A1C? And we actually go through this type of manual and do a manual assessment. And really the first step within the modernization of that process was helping to automate some of that assessment, right? So even before stripping away some of the more cumbersome pieces of evidence like fluid collection, the first step was to do something called the creation of a rules engine. So instead of having an underwriter physically go through, do all the selection by hand, what they would do is for many cases they would make essentially a rules engine or an automated decisioning system that could take that information, digitize it, ingest it, and make a decision. Now, this doesn't cover every single case. There are obviously some cases where that wasn't possible, but really this is the first step to approaching some level of automation and sophistication within the underwriting process. Now that was sort of step one, and this came through the advent of computers, technology, but really further to that, and really where data science come in, is in the increased sophistication and the automation of underwriting. And really what I mean by that is the underwriting process, as it historically was, involving the collection of fluids. It's a very long and not, customer focused process. If you're somebody applying for insurance, you don't want someone to come to your house, stick a needle in your arm, and then have to wait 30, 40, 50 days for somebody to go through and review that and get back to you with a decision. So there's been this big push to automate that. And the first step was the rules engine, but further to that was actually the removal of some of those requirements themselves, right? So people said, hey, can we actually do this process without collecting fluids, without taking this long? And really the big driver of being able to do that was the advent of data, right? The whole reason for collecting fluids in the past was because there was no other way to ascertain the level of information needed to assess risk. But in the 21st century, with the proliferation of data, you now have these alternative data sources that can allow you to make that risk assessment without the need to do that, right? So just some examples that I can talk about in a bit, but things, like medical history, prescription history are some of the big drivers of that. And then additionally as well, having a collection of not even direct data on individuals, but general data on the underwriting process and how individuals behave would allow you to also layer on additional, you'd say, intelligence to help mitigate some of the risks of what we call accelerating the underwriting process. So, in addition to adding new data sources in to underwrite and replace the older, more archaic data sources like fluids, there's also additional intelligence through the use of certain models to identify individuals who are likely to do things like misrepresent their risks on their application to help further mitigate some of the potential risks that come with changing the process, right? So as an example, one of the things if you ever apply for life insurance that you get asked on a life insurance application is whether or not you smoke, right? They'll say, do you smoke? Or if you don't smoke anymore, when was the last time you smoked? How often do you smoke? Things of that nature. And as you can imagine, people know that saying that you smoke is likely to increase your price. And so, oftentimes this is a source of non-disclosure or misrepresentation. People will, lie about that on an insurance application. And historically, when you collect fluids, there's actually a lab value called a cotinine test. And you can use this cotinine test to actually determine whether or not someone does smoke, because it remains for a while, even after they haven't had a cigarette within their blood. But if you remove that now, you're left susceptible to people just lying without any recourse or ability to determine that. And so, one of the ways you attempt to mitigate that is through the use of a misrepresentation model. And so what an insurer might do is they may have a process whereby, most people coming in will be able to, get issued a policy without the use of a lab value. But for certain people or certain subset of individuals who, based on other pieces of information, are very likely to misrepresent the risk, they can actually do what's called a kick out and send those people to have fluids collected. And what that does is it allows you to, provide a streamlined experience to the bulk of people while still, identifying the people who are most likely to, misrepresent or create an adverse risk. And so you minimize the additional, you can say, mortality or expense, claims that would come on your book of business, while still, improving the customer experience and sort of optimizing in that respect. And so really that process of accelerating the underwriting process, removing fluids, and incorporating all these additional layers of intelligence, meaning new data sources, new models, new ways of thinking about assessing risk, have been a big focus within the life insurance space over the last 10 or so years. And as part of that too, it's sort of a twofold approach, right? So you have not just the building of models and the use of new techniques, but you have the advent of new data sources. You have validation and exploration of those. So as a first step, understanding if a new data source presents itself, is it valuable for assessing risk, and then further decisioning off of that. So it's this constant sort of feedback loop as a result of this increase in technology and proliferation of data, where we have new data sources, new technologies, and they build upon one another to really optimize this risk assessment process. And additionally, I think, in more recent years, we're moving into further sophistication there. So historically, one of the first introductions of machine learning within this process was in those misrep models that we talked about. So before they were actually used to assess risk directly, they would be used adjacent to the core of the risk assessment. So this would be, not directly saying, hey, this person should be issued a policy with this rate, but you should maybe look more into this person. There were tools to enable the optimal assessment of risk versus actually assess the risk itself. But I think more recently we're starting to see an increased use of models, particularly built off of some of those new data sources like medical and prescription data, to actually do more direct risk assessment. Obviously with lots of controls and due diligence there. One other, I guess, tidbit there to kind of touch on is, and I'll talk about this in a few minutes, but the team that I work on in particular is North American focused. So we work in both the US and Canadian markets. And within both markets, there's been this, push in tandem to do the same thing, which is to accelerate the underwriting process. But the markets within Canada and the US are vastly different. Within Canada, we have, I would say, much more rigid data privacy laws. And because we have a much smaller market, we have just less available data sources. When you compare that to the US, they're a much larger country. They have, I'd say, much more lax data privacy laws and much more available data sources. And as a result of that, there's a lot more sophistication, I would say, in the US than in Canada currently. Although, in Canada, we still do make use of some of these things. I'd say it's a little bit behind as of late. And there are different challenges that present themselves when attempting to do the same things in Canada when compared to the US. One other thing I'll just touch on, just to give a bit of background on the underwriting process, is really some insurance lingo, I would say. So I talk about risk assessment and the process of people applying for insurance and being given a policy. As part of that process, people will be assigned what's called risk class, right? So this could be what you would call a standard risk class, sort of normal, regular insurance product. You can be issued a preferred product, which is something that indicates more preferred health. But then on the opposite side of that, you could be issued something that's substandard all the way up to what's called decline. And so some people who apply for insurance because of various reasons maybe decline coverage, right? In the context of auto insurance, this could be people who've had just too many accidents and whatever else. It could be that on the life side, it's people who have just too high of a risk and they can't properly assess the risk. But part of building these processes is to ensure that you can still assess risk and still mitigate the chance of declinable risks making their way into the insured pool. Because one of the consequences of that is, because you can't properly assess the risk of declinable risks, then it does actually increase the price of everyone's sort of insurance there. As a secondary aim, though, one thing I will say is historically, what was thought of as a declinable risk for whatever reason, it could be people who have certain medical conditions and whatnot, is changing because of the advent of technology. So, in the past, while you were reliant on less data to do your risk assessment, that meant a lot of approximations and heuristic type assessments. And so what they could mean is that, you have just medical judgment that would go in and make a decision as to whether or not you could insure a condition. With the advent of more data, we do have a lot more visibility and understanding of health in all dimensions. And so really one of the positive consequences of that is that we're starting to really expand insurability to previous pockets of individuals who otherwise wouldn't have been able to get insurance in the past. And so that could mean, just greater understanding of a condition, greater understanding of the mortality impact, and the ability to actually offer insurance to them at a price, right? And then, some examples of this, partially driven, I think, by the advent of better medical technology, is things like HIV, which in the past was more difficult to insure. Now, because of greater medical technology, is now a condition that can be insured as a chronic condition. So I've talked a lot about, what insurance is there, what, the difference between life and property and casualty insurance is, and really the risk assessment that goes into it, and where life insurers' heads are at in terms of incorporating technology into the core risk assessment. And I'll just talk quickly about what reinsurance is, because this is specifically what I work in. So reinsurance, as I said, sort of at the beginning, is insurance for insurance companies. And so it's another layer of risk management. And there's a multitude of reasons why an insurance company would seek reinsurance. And I've sort of listed some of them here, but you can think of, the top of your head, just a few cases. One could be diversification, right? So you could have an insurance company that has a lot of exposure within a certain line of business or a certain area, and they want to offload some of that risk, or they want to, increase the diversification of their business. You can think of tail risks, right, as another one. So, as an example, I have here like a bad hurricane year or a pandemic, for example, things that, an insurer might be able to cover year-to-year business, but in the event of a large event like that, wouldn't have the surplus or the capital to cover it. They could approach a reinsurer for, coverage of those tail risks, or stop loss coverage as well. And then on the life side, one of the other big reasons is financially motivated reinsurance. And so, not to get into too much detail, but there are a lot of laws around capital that has to be held within insurance. And so one of the reasons that a company could approach a reinsurer is to help them free up some capital to be invested in more profitable uses, right? So there's really this whole market of different types of reinsurance products and structures that insurance companies look for, and the reinsurance industry really exists to meet those needs. And like any industry, it is a market. So I work for, say, the largest in the world, but there's a handful of larger companies, a lot of smaller companies, and we all compete to win business with insurance companies. And so our customers are insurance companies. We are attempting to sort of win those deals. One of the things I have as the last bullet point here that I think is kind of interesting about reinsurance that you don't really get with other types of industries is that one of our mandates is really to not just win business with insurance companies, but also partner with them, right? So that means providing things like risk assessment solutions, machine learning solutions, product development solutions, and not just in a purely consulting like fashion where we provide advice, guidance, products, and sort of that's it. With reinsurance, because these products involve the transfer of risk. What that means is that any solution that we provide or implement actually affects us as well, right? So, as an example, that if we were to make a change to an insurer's underwriting process, and that change were to adversely impact their risk assessment and hurt their profitability, because we reinsure that business, that would also affect our bottom line. And so, one of the results of that is that we have skin in the game, essentially, right? Any recommendation or solution that we pitch or implement, we feel the brunt of it. We can't just sort of wash our hands clean of advice and say, hey, this is on you. We really have to do our due diligence and be sure there, because it's not there is responsibility there and impact to us. And I think with a lot of industries you don't necessarily sort of get that. It's more of a transactional relationship. With this, it's really they become tied at the hip almost, in a sense, and that your business is on both ends. And so very interesting, I guess, relationships and structures as a result. So, as I mentioned before, I work on a North American team. So our team is called North American Integrated Analytics, and we're primarily based out of New York City and Toronto. So I'm in the Toronto office right now. We have a New York City office, and we operate in both the Canadian and U.S. markets. And so I have here a list of things we work on. One of the big things we work on, as I've talked through there, is accelerated underwriting. So improving the way we assess risk, and that comes from a few large areas and products that we do, as well as some more tailored type solutions, right? So some of these tools involve the production of models or you can say rules to help insurers assess the risk. It also involves the incorporation of new data sets and new data sources, I should say. And that involves really a few different things. So our team will both identify, source, extract, and validate new data sources. An example of that could be in something called the electronic health record. Within the life insurance space, electronic health records within the more recent years become one of the predominant prospects for a risk assessment tool. And so one of the mandates of our team could be to get EHRs, extract information, understand the value they bring to risk assessment, and really build out any solutions from that. So I think we're focused not only on the end product of building a model, but also sourcing, understanding, and creating that, right? The whole sort of end-to-end chain, you could say, of building out machine learning analytics solutions for the life insurance industry. One of the other areas of focus, it still touches on risk assessment, is improving policyholder health and behavior, right? So if you think about the way insurance works, the company underwrites individuals, then they make them an offer, and then potentially they accept the offer and they take up a life insurance policy. And so now the company has 100,000 individuals who have life insurance policies, and those individuals will be paying premiums, and some of those individuals you have to pay a claim for. You have that one point in time when they're underwritten to assess the risk, and then as I said at the beginning, when you have that block of 100,000 policies, if you misassess the risk, you can't go back and increase the price or deny anyone coverage, right? You sort of have those 100,000 individuals, and the amount of claims they have are out of your control. So one of the areas we also focus on is trying to understand ways to once somebody has been underwritten, help encourage healthy behavior, or implement initiatives to better the health and wellness of policyholders to extend their lives, which has the benefit of reducing claims, right? So I think that's one of the interesting things as well, is that the solutions within life insurance are typically positive. Anything that's positive for the life insurer is typically going to be positive for the individual as well. So things like extension of life and reduction in mortality are things that while they provide material benefit to a life insurance company and that they don't have to pay out claims, they're also good for the population as a whole. Extending lives and things like that are altruistic endeavors. So there's sort of a positive there in terms of the work that we do. And then one of the other things that I also touched on was this idea of expanding insurability. So in the past, because of just a lack of data and more rudimentary understanding of human health and risk, we couldn't adequately assess everyone's risk. And so oftentimes life insurers, if they are uncertain about how to assess risk, or they think it might be high and they don't really have the tools to understand it further, we'll just go, we can't offer a policy. And so that leaves a whole segment of the population that does not have life insurance, and there's an unmet need within the market and within the industry to meet those people's needs. And so one of the things with the advent of data is trying to understand ways to assess those people's risks, right? To expand insurability to people who are previously underserved within the market, and be able to offer them insurance and provide them the coverage and the peace of mind that comes with life insurance, right? And that's directly a result of new data sources and increased sophistication there. Some of the other things we do that we focus on are the security and the ethics side of things, right? So that spans a few different areas, namely one of which is data privacy, right? So, staying in the forefront of things like data privacy laws and ensuring that when we are using data sources, we're doing them in a compliant way, making sure we're storing and safeguarding data when we are custodians of that data are big, and making sure we have robust security processes and protocols in place to ensure that any data we have and any process we have in place is secure in the current world, which is increasingly becoming target for various actors, right? So those are some of the things we focus on as well. And then I think another big part of that is, I say here the ethical practices, but that's things like bias and fairness. So, underlying all of these models, tools, data sources is an assessment. And we want to ensure that whatever assessment we are making is fair, right? What that means is we don't want to build a model that assesses someone's risk, and it turns out that that model has some sort of innate bias against a certain, race or ethnicity or gender, right? So I think one of the big focuses of our team historically and continuing all the way to now is really making sure that we're, leading in best practices in terms of both understanding the way biases can come into models and different analytics tools, understanding ways we can identify them, mitigate them, and then also really forwarding that in the industry. So our team does a lot of work with different regulators, particularly in the US, to help them shape legislation and regulation around the use of tools within the industry. And that's to make sure that we're innovating, we're improving the way we assess risk, we're doing so in a way that isn't harming individuals and society at large. So that's another big focus of our team as well, is really focusing on that. On the right here, I have just a list of different positions that we have within our team. So I work on the data science side. As a data scientist, I'm a staff data scientist now. And really what that entails is, the building of machine learning tools and analytics solutions. And so a lot of what a data scientist or somebody like me would do would be a mix of different, I'd say, projects related to building out those risk assessment tools and also validating them and implementing them. I would say on the data engineering side, within our team, we have, say, a variety of different focus areas for data engineers, but some would focus on more traditional data engineering in the sense of ETL, pipelines, databases. We also have data engineers that focus more on security. We have some that focus more on infrastructure. So, I'll get into this in the next slide, but we use Azure as sort of our cloud platform, but making sure that all the resources we use, whether it be virtual machines, storage accounts, things of that nature, kind of functioning and upkept. We also have software engineers. So within our team, we have sort of more bespoke solutions, you could say. So you can think of like a more simple deployment or a tool or an analytics product potentially that we provide to a specific company or in a more bespoke fashion. But we also have a few larger, you can say, pieces of software that are, within them contained a more robust set of risk assessment tools. And so, to build those tools, we have software engineers in our team that will take, the models and whatever tool we build and help frame that into a piece of software that we actually bring out to the market, right? Then we also have machine learning engineers, and they kind of sit in between, I would say, data engineers and data scientists, and that they have sort of a mix of both skill sets, I would say. So they typically work on a lot of the underlying infrastructure we use to actually train and deploy models. So things like automatic deployment, monitoring of our models for things like model drift. We have a platform that does that in an automated way, and the machine learning engineers build and maintain that. And they also help do things like containerize and promote some of our models. And they work as well on, as related to the monitoring aspect, how some of the bias ties into that and how you can automate that. But they oftentimes sort of straddle between that line between data engineering, data scientists, and having a skill set that kind of touches on both. We also have sort of a DevOps team, and that DevOps team focuses on deployment of our big tools, essentially, or our big piece of risk assessment software. And then interestingly, one of the things that our team does is we have, ingrained within it, underwriters and operations. So all the solutions we build, whether it be a model or a piece of software, or even just presentation or recommendation analytics type of project, we don't do that in isolation, right? We do that in conjunction with the people who have intimate, deep knowledge of how risk assessment has been done in the industry historically, which are the underwriters, right? So within our team, underwriting is involved in the development of these things to make sure that they're still relevant to the business at large, right? And they're still understanding the nuance of how these things are assessed. And really, I think our team has never really been of the mentality that we're seeking to replace the underwriting process, but we're trying to supplement and better that process. And to do so, we work hand in hand with the individuals who, as their trade, know it the best. So I'll talk a little bit about some of our tech stack here. So as I mentioned, we do use Azure, and I think most companies nowadays have some sort of cloud provider, whether it be Google or AWS or Azure. So we do a lot of things off of Azure. That includes having things like our SQL databases. We have storage accounts, right, for storing some more unstructured data. We have virtual machines that we work on as well. So we typically don't do a lot of work on our local machines. We have virtual machines that we actually use to do things like train models. And so one of the interesting things there is it's analogous to just having like a Linux computer, you could say, but we can do we can scale these devices. So what that means is that we're not bound by whatever memory or processing power you might have. In a fixed sense, you can go in and dynamically change that to suit your needs. So if you're working on a project that, like I am right now, where you're working with a data set that has 100 million individuals and thousands of pieces of information on those 100 million individuals, and you need more processing power, more memory, you can quickly kind of do that and dynamically alter the device you're working with. A lot of what we do is in Python, I would say, as well. So Python has sort of become like the standard within our team in terms of developing models and even building a lot of the software that we have. So we're primarily, Python shop. We also obviously have a lot of SQL and some of the front end stuff on the engineering side that we work with. But I would say for me, it's mostly Python, some SQL predominantly. Historically, we did use a bit of R in the past, and I think there still are some uses for R, but I'd say it's less common now. It's predominantly more of a Python implementation on our end. And then another thing we do use is Databricks. So Databricks is sort of like a say, web-based platform. And there's different uses for that. So you can do things like orchestrating pipelines for model runs, things like that. It is web-based. And so it mitigates some of the localized issues with certain things. You can have shared access on a sort of web-based interface. You can scale different things as well. And then on the back end, it allows for a lot of distributed computing. So if you're working with very, very, very large data sets, things in the order of billions of records, it's not really feasible to use just normal Python code or normal computers, you could say, to work on that. So you have to make use of Spark or distributed computing languages. So we use Spark, for example, or PySpark, and we use that on Databricks. And so that allows you to distribute your computations and work with much larger data sets as well. And then I have here as well, just the bottom is Kubernetes. So we deploy applications through Kubernetes, and that's more on the engineering side, but that's one of the ways that we do deploy our tools. So here, this is really just going over our problem space again, right? And understanding like why we focus on what we focus on. So, I think, as I said at the beginning, historically within the life insurance space, there was always slowness to adopt innovation because of that risk aversion that comes about through the permanence of mistakes, you could say. But I think there's really been this push for improving that experience, and it's one of those things where once somebody started doing it, everybody kind of had to follow within the industry, and everyone's trying to do that as quickly as possible, also mitigating the risks they bring on their books. One of the pushes of that was the increase in data sources, increase in technology, and also just demand for better experience. I think in the 21st century, people don't want to wait 60 days for something. It just seems excessive when you can do anything in a matter of minutes online. Why do you have to wait 2 months for an insurance policy? One of the interesting things, though, as well, was that we had COVID a few years ago, right? So prior to COVID, there was already a big push to move into this accelerated underwriting space and to minimize the amount of fluids that were collected within the risk assessment process. But COVID came about and kind of forced that process to accelerate a little bit, forced the acceleration of accelerated underwriting, as you would call it. And one of the reasons for that is that, for a moment in time, all the ability to get those fluids was gone, right? So at one point, everything shut down. Companies still wanted to continue to write business and to make money, but they could no longer actually send people to people's houses to collect fluids. These testing centers were closed. And so they had to figure out a way to still write policies. And so there's a lot of process changes as well. But one of the results of that was that they started really pushing for accelerated underwriting much quicker. One of the, aspects of the move to accelerated underwriting is that it is rolled out in sort of a gradual fashion, right? So it typically involves a gradual process of first eliminating the requirement to get lab tests from the lowest risk populations, and then gradually increasing that to higher and higher risk populations typically as you get more and more comfortable and you have more sophistication and tools at your disposal. So as an example, typically younger ages are the first to be offered accelerated underwriting because younger individuals are typically just better health. There's less medical complexity, generally speaking, and overall it's a population where there's less potential for adverse risk and declinable risks and things of that nature. And another one is in what you'd say the lower face amount groups. And so face amount really just describes how big the policy is, how large it is. And, the smaller the policy, the less financial risk. So typically lower face amounts, lower age is were the first to be offered accelerated underwriting. And then they gradually sort of introduce that to slightly older ages, slightly higher face amounts. With COVID, though, that was kind of accelerated. So people raised their limits much quicker and sometimes suddenly. And then, post-COVID, people didn't pull back, right? They kept these new face amount age requirements where they were. And it's been the new paradigm. We only move forward beyond that. So here, this is the last slide in the first section before I open the floor to questions, but I'll quickly talk through just some of the challenges that we face within the life insurance and life reinsurance industry when it comes to doing data science, essentially. So the first was lack of digitized data. Now, this is becoming less of a concern nowadays, but when I first started, and I think even a few years prior to that, this was a serious problem in both Canada and I think especially in the US, where with those older life insurance applications, not only were they underwritten by hand, but they were also filled out on pen and paper. So a lot of the, you could say, data that existed on risk assessment was paper files and didn't exist in digital form, right? And oftentimes that was something that continued up until recently, where all of the process of applying and getting life insurance was done on pen and paper. And so obviously, if you're trying to understand risk assessment, build tools, and you have no digital data to work with and no digital platform to build anything on, it kind of sits as a roadblock to doing anything, right? So that was really a big roadblock initially, was that you had some life insurance carriers, I think particularly some of the smaller ones in the US, where they just didn't have any digital data to work with. And so you couldn't even understand, for example, who in their process was likely to misrepresent, and you couldn't build on any sophistication there. And so that kind of slowed things down. The other is really the lack of data standardization. And so this is really in a few ways. One of the things is that there is no one standard for collecting this data. So even things like how a question is asked between different companies is not going to be standard. And so on the reinsurance side, when you're looking at all these different types of data, there's no way to apply sort of what you've already done to new data sources. And so there's a lot of duplication of work and a lot of overhead that comes with new tools and new projects, right? So as an example of that, one company might ask you on a life insurance application, do you smoke, right? You could say yes or no. Or do you use tobacco products? Yes or no. And another company could ask, how many cigarettes do you have a day or something? Or another one could ask, how many years it's been since you smoked? Or another one could ask, in a different way, do you, use cigars? Do you do this or that, right? And there could be, 20 different ways that different companies ask for more or less the same piece of information, but they leverage it in slightly different ways. And so when you're attempting to kind of standardize that data, it presents a challenge, right? You might have a model that uses, tobacco history in the last 5 years, but then this company only asks for the last 2 years, or this one asked for in the last 5 years, they excluded vaping and cigars and whatever else. And so now you have populations that are slightly different, right? And the tools don't really fit. And so there's some challenges there potentially. And that's just a simple example, but that kind of thing, yes, is across the board in different areas. And so that lack of standardization, the approach and the way data is structured and the way data is collected, it's always been an issue. And then I think an additional aspect to that has been the lack of format of standardization. So the type of data that we would typically get varied heavily in really the structure we would get it in. So this could be anything from CSV files to XMLs and JSONs. Sometimes you get screenshots and you use OCR, but really, the type of data and the structure of the data you would get lacks standardization as well, which presents a challenge in terms of the work that's required to actually parse it out and get it into a usable format. One of the other ones is, I say, lack of existing consents to use third-party data. So this is a predominantly Canadian thing, I would say, in that we do have data privacy laws, and what that means is that data about your data, you could say, can only be used with your explicit consent, right? So if you were to apply for life insurance, you might have a consent on that, and they say, hey, can we reach out to your doctor and get medical information? And if you say yes, you've given your consent, and then they can reach out and get medical information. That applies really to all types of data, right? So that could be anything from ad data to political polling that you've given or whatever else, right? we have very strong consumer protections around storage, use, and consent of use of data, which is good from the consumer perspective. And typically, what that means is that there's no actual obstacle to using any data source, so long as you have the consent from individuals. So you can, ask for data or ask to procure data for somebody, as long as they say yes, you can use it on a go-forward basis. But some of the difficulty there is that, if you were to use a data source going forward, you want to know how to use it, right? And in order to know how to use it, you might want to build a model. But if you don't have historical data to build the model on, then you don't know how to use it, right? So it's one of those things where you might get access to data source, and you might have the ability to update consent language and use it. But there's actually like a burn-in period where you have to actually collect the data without really knowing exactly what to do with it before you built up enough of a set of data to actually understand it, build tools off the data set, et cetera, right? Another one I said is there's a higher bar than other industries for adoption of new tools and techniques. And so because of the risk aversion and the slower adoption of new tools, typically this is a lot of hoops you have to jump through, or a lot of due diligence that needs to be done before things are adopted. Speaking, somebody who's worked in other industries, I'd say, typically people are more willing to make decisions or adopt new tools off of a lower amount of information in other industries, whereas in life insurance, people really want to understand the nitty gritty, understand it in every aspect, and do, just additional validation, due diligence, understand impacts and project how things can change over time before they implement. And then even when they do implement, it's typically done in a more controlled fashion. So I'd say there's typically a lot more work that needs to go into building out a tool and implementing a tool within the life insurance space and other industries. And then again, another challenge we have is in the Canadian market in particular is just the lower availability of data sources. So, and part of that is driven by data privacy, but I would say the majority of that is just driven by the fact that we're a smaller country and there's just less data available. So again, the US, for example, there's a lot of marketing data sets out there, things of that nature. But in Canada, there really doesn't exist as much data. And so it presents a challenge when you're seeking out the same goals as your US counterparts, trying to accelerate the underwriting process, but you can't replace fluid values with other alternative data sources, right? You have to get a little more creative in the types of tools that you use, right? In the US, for example, one of the common data sources that collect sometimes now is prescriptions. So when you apply for insurance in the United States, they'll ask you, can we do a check on your prescription history, and then they can pull a data set that has the medications people have taken over a certain amount of time and use that to help assess the risk. That's not something that exists currently in Canada. And so you obviously have differences there in what we can do in Canada versus the US. And then there is a higher regulatory involvement within certain business areas. And so what I mean by that is, underwriting is one actually where, while there is a lot of regulation, it is more open to new tools, and there's less direct regulatory, not involvement, but less scrutiny, you could say. Whereas in areas like pricing, for example, or reserving, which is essentially the financial statements, which are big areas within reinsurance and insurance, they're very, very heavily regulated. And so there's less room to implement new things. So that mentality you have with risk aversion that comes across, all business areas within the life insurance space is, I think, particularly more prominent within areas like pricing, right? So because of the regulatory involvement and the aversion to rapid change, it becomes very difficult to implement solutions really within those spaces. Although it's not impossible, it's just more difficult. And then finally, I think the evolving regulatory landscape is definitely a challenge that we have to deal with. Although I'd say, with our team, typically, we've tried to stay at the forefront of that and kind of be the ones to push how regulators see the industry and regulate the industry. But that's definitely, a challenge. I think that companies probably in all industries, but particularly within life insurance, are facing is You have new tools. You might have Gen AI, for example, large language models, and you want to use them for certain things. Regulators don't really know what to do with them yet, and so you build something, and then a new law comes into place that puts a requirement on how they can be used, and then you could be in a position where you can no longer do something, or you want to kind of future-proof your solutions, and so you can sometimes be playing a guessing game as to where regulators will be, and so that's definitely, I'd say, a challenge in general for data science within insurance, is staying at the forefront of that and then trying to future-proof yourself for potential changes, both in the bias and fairness space, data privacy sense, or just general regulation on acceptable use of different tools and data sources. One of the things in the U.S., for example, was historically, credit data was something they made use of. So insurers could order credit files and use that as a way to either directly assess or supplement the risk assessment. And that's come under a lot of scrutiny more recently due to bias concerns. And so I think it's fallen out of favor in the US. And so that's an example of just, tools were built and weren't future-proofed, and then the industry moved to do away with them. So it's always a challenge to do things to make sure that things like that don't necessarily come about. So I just talked for like an hour. A lot of information there on life insurance underwriting, our team, the industry, but I'll just pause and I guess open the floor for questions. Oh, I see. I didn't see there's 21 messages. Sorry. Kaylee, should I go through these or should I?
Yeah, maybe we can work through the chat and then take up any like a couple of hands as well. Would that work? Maybe
Yeah.
4 or 5 hands, depending on timing.
Yeah. I'm just looking at the person. Can we get referral discount on car insurance? That's funny. So that's actually funny. So I work in the life and health side. So I actually don't have any involvement with the car insurance. I actually just had to get new car insurance, and it was also high for me. So I don't really know a way around that. I actually don't even, because I don't work in that field, I don't even have a really thorough understanding of the models and things they use and the pricing strategy. So I wish I could advise you on like a way to better your application, but unfortunately, that's out of my practice area. So I also suffer from high car insurance rates we have in Ontario. I'd say one piece of advice is don't live in Toronto, because my wife, when she changed her address from her hometown of St. Catharines to Toronto, her rates like 3x, which is wild. Yeah. And then someone said 1,000 years behind. I guess that was in reference to like the process being like 60 days, and in the 21st century where you can get everything, the blink of an eye, snap of a finger. Yeah, it definitely, life insurance is an industry that's definitely lagged behind, I think, others in terms of how quickly it's innovated. And I think it's starting to change in the last 5 to 10 years, but definitely been slow, even compared to property and casualty insurance. So you can think about car insurance or home insurance. There's many providers right now. You can go online and get a quote or even get a policy issued instantly, and that's really only become a reality in life insurance more recently. But even then, I would say it's still not the predominant method of getting life insurance. You're typically still going through another channel, and there's still some small weight associated with it. But we're working on it. We're improving as quickly as possible, but there's still definitely catching up to do in terms of how we compare to other industries. Yeah. Yeah, definitely, slower industry. I think some of it's justified in the sense that, if you issue a bunch of like $5 million policies and you're a little too aggressive in terms of your rates, and then you have more deaths than expected, like you can take millions of dollars in losses, right? So there is like a good reason for being cautious, but definitely, yeah, work to be done for sure. US is a free for all. Yeah, so it's not a complete free for all, but I would say like there just is a lot more data. I mean, they still have privacy laws, especially as it relates to health data. So you have HIPAA in the US, which governs how health data can be used. But there's a lot more available data sources, I would say, especially on the marketing side. Funny enough, I was going to say with some of the Doge stuff. There is weird things happening with Social Security death reporting right now, which is kind of a interesting thing, but I won't get into that. But yeah, there's definitely some stuff going on in the US. Someone said almost like options trading. I guess maybe that's in reference to reinsurance. Is that, maybe clarify what you mean by that?
Yeah, that's correct. So you know how you underwrite reinsurance,
Yeah,
leverage the risk,
yeah,
de-risk.
yeah, yeah. Well, it's a good point. So, I guess a bit of background on me as well is I don't work in an actuarial area. I am like a partially qualified actuary. Like I'm an associate of the Society of Actuaries, and so one of the things is within the pricing of life insurance, you have the concept of, it's called an embedded option. I'm getting very technical here, but really like
Yeah.
uh, you can think about like the way you price the insurance is that you can break it out into essentially an option on whether risk is going to move in a certain direction. So it's kind of interesting. There is definitely a time there to finance, and then a lot of the more traditional actuarial side of things involves, where that capital goes and how financial structures are set up for those products, and it gets very complicated and financy, which is kind of cool. So that's kind of an interesting part of the industry, definitely. How does a company like yours formulate data governance policies and structures? That's a good question. So we actually do it North American wide. I mean, we have an internal risk team that set up a lot of our overarching, structures. But what's interesting too is that we are a German company, so Munich Re is based out of Munich. So there is a central division that has sets of policies. But we also have different subdivisions, you could say, right? So North American Life and Health would be one. And then you would have obviously the top level guidance, for example. Then you could also have specific things to whatever market you're working in. So our company would obviously have broad level governance policies, but I think our team in particular also builds on top of that. So we do that from like a North American perspective. So what that really entails is we have somebody who's responsible for kind of managing all of our policies and structures and ensuring that they're followed from a North American wide perspective. And oftentimes, what's interesting about that is that things can move a certain direction in one market, and we might implement it in another market, even if it's not strictly required, right? And so, as an example, a lot of what's happened in the US in the last few years has been movement away from certain non-traditional data sources, things like credit data, for example, and increased scrutiny and requirements when you do use that. So they have very rigid bias testing requirements as mandated by certain states. Like Colorado's one, Florida, and I think California have laws around this now. And so obviously we built, I think we generally moved away from things like credit, for example, but we built policies around monitoring and reporting to regulators and assessment of bias in the context of these data sources. And it's something we can operate and implement North America wide, even though it's not necessarily something that is relevant in Canada as of late. It's something that we have the ability to do in Canada if the need be, and we kind of keep things standardized in that respect. But there's like a lot of, I would say, data governance policies and structures too. Like there's all the way from how we store data to how our access is set up, to retention, right, are all big areas of focus. And I think areas where a lot of companies are playing catch up right now. I think like we've been pretty good in terms of staying on top of those things, but just knowing people in the industry, I think that's an area there's a lot of rapid evolution. I think particularly in the context of this LLM explosion that's happened over the last year or two. Now people are asking questions about intellectual property and how that relates to data and data security and all these types of things. And regulators are moving, and people are now going, okay, what kind of policies do we have to implement, right? How do we make sure whatever we're doing is done in a safe manner and whatnot? So yeah, definitely like a lot there. The next question is, can you please provide examples of activities you do as part of developing and validating machine learning tools? Yeah, okay, good question, I guess. So, I mean, I guess could you clarify, like, do you want to know more in terms of like technical development or more just processes in place around developing like models, for example? I think it's Nastran.
I think
Yes,
Yeah.
my question was about
Mhm.
technical actually, so about the
Okay.
skills set, but you already
Yeah.
answered this partially. My question was
Okay.
before part of your presentation.
Okay, no worries. Yeah, I mean, if there's any other technical questions as well, feel free to ask. But I guess yeah, like we have a lot of different, I guess, processes, and a lot of our, I guess I'll quickly say, like, a lot of the models we build are related to risk assessment, and they're either related to things like, you know, misrep, and so we'll use a lot of things like boosted trees to model, you know, misrep and classification. We also do a lot of, we say, Poisson modeling. Mortality is distributed in a Poissonian fashion, and so we implement a lot of other Poisson GLMs, or there's now boosted. There's Poisson boosted trees now, which is kind of interesting. So we'll do stuff like that to model mortality directly sometimes. The other thing I haven't touched on is that because of that increased scrutiny, there's also I'd say an increased push to have very interpretable tools and techniques, right? So some industries are, I think, are more comfortable with more black box-ish algorithms than others, right? Life insurance definitely puts a surplus on interpretable algorithms, especially in the context of things like pricing, right? So even if you are to build a more complex tool, you have to build in complementary interpretability to make sure that you can explain every prediction that's being made. So I think, you know, a lot of times you'll use simpler model paradigms, you could say. I wouldn't say simpler, but, you know, GLMs, right? For example, or GAMs. And then we will use, you know, boosted trees or random forests and things, but, you know, we'll make use of like SHAP values and different ways of reporting those just to make sure that things are interpretable. And then I'd say, like, for, you know, deep learning, there's definitely uses, but there's more scrutiny around them, and more aversion to using less interpretable methods. Where would we fit in your team stack hypothetically? So I would say probably more around the data science side, I would think. Kelly, remember the streams again? I remember there's two streams for the certificate. Oh,
sorry, I was clicking on
no,
mute.
no worries.
Yeah, they haven't selected a stream yet, so everybody is kind of in the general combined one right now.
Okay. Yeah. So I mean, I think my mind would go. Oh, sorry.
Sorry, it's two streams: data science and machine learning.
Mm-hmm. So probably like the data science MLE more, I would say, because I think it's most focused more on like the modeling and that side of things, like the actual machine learning portion. Like our engineering team, I'd say, focuses less directly on the data science aspect and more on just either software engineering or some of the infrastructure around it. And while it like supports and enables, I think, a lot of the data science, it doesn't directly do the data science, right? Like our engineers would be building models that wouldn't really be, they might do some deployment, but they wouldn't be thinking about, like, you know, how to structure an endpoint or like how to structure interpretability, things like that. It'd be mostly just, you know, the pure engineering component piece of it.
Thank you. Have you seen any cross between business and technology? Like, for example, a lot of us are from different backgrounds, switching careers. So, like, have you seen any sort of that? Like, you know, someone in the business side or sales side have a knowledge of data science, and does it help? Like, does your company something like that looks forward to, or maybe in the future?
Yeah. So one of the things I haven't listened here, you brought up sales, is that we do have sales and like business development, I guess, that is embedded within our team now as well to kind of deal with those solutions. And so I think, like, even if somebody wanted to focus on like a less directly technical role, I think it definitely still enables that there. If you're talking about people like kind of transitioning from other areas of the business to something more technical, that definitely does, I think, happen as well, right? So like one example could be, again, the context of life insurance, you'd say like the people who understand the business would be like actuaries or underwriters. So you definitely see a lot of movement from those sort of fields, or even claims people, things like that, from those fields to more analytics or data science type roles, right? Like as an example, on my team, we have actuaries who've transitioned. And then I think even within our team, like people from different educational backgrounds and things like that as well, and people who've worked in different industries. So I know some people who've worked in like very non-technical consulting and then have transitioned, later on, or people who worked, did their education in like, psychology or math, or there's many different, I guess, majors and backgrounds, I think, that led to data science. So I'd say yes, like there definitely is paths there, and then definitely different paths bring different strengths, right, of either different business areas or different skill sets that can definitely supplement the role. One last thing I'll add to that is like a lot of, when people think of data science, they think a lot of the technical portions of it, which is building a model. But I think a lot of what I do and what I do increasingly more of is like the sales of it, more or less, right? So you build something up, but you have to convince people that it's worthwhile to do, right? And that could be selling an idea internally, maybe selling it externally, right? Pitching to a client, or trying to get buy-in from an internal stakeholder to commit resources to that. And so I think that's where some of those other skills can also come into play, right? Different backgrounds can help with that for sure.
Thank you.
No problem. Do you use Canadian data and US data separately for your predictive analysis? Because demographically, I assume very similar, but I might be wrong. Wait, I bet the lack of gun control on the US skews the data, increased risk. So very good question, actually. So like you could say somewhat, yes, they're similar, but in certain ways they're completely different, right? So the US, for example, because of their healthcare system, things are very different. Any sort of health data is not going to be applicable to Canada and the US. And then even just demographics and risk trends and things like that vary a lot, right? I think tobacco use is different, alcohol use is different. Their life expectancy is lower. And they also have a lot more, one of the big things, they have a lot more income inequality than we do in Canada. And that directly influences mortality. So you can see this in data. If you split up mortality by income band, like people in higher socioeconomic bands will have better mortality. And that is something that comes into play in the US a lot. And obviously that's still true anywhere in the world, but I think if you have less income inequality, you see less of that variation and disparity. They also have a very different, you say, insurance market and product structures down there. So one example is they have what's called like final expense or funeral insurance in the US. And this is really like very, very small policies sold to very low socioeconomic status individuals. And there can be some high pressure sales down there and a lot of things like that. And so when you're looking at like the insurance side of the data, not just other data sources, but how risk is assessed, the types of people that will apply for insurance, things like that, definitely varies a lot between Canada and the US. I've never thought about the gun control one. It's kind of interesting. Like we do have cause of death sometimes, like claims. I do wonder if there's more accidents and things of that nature. I know during COVID, for example, there were some differences as well. I think part of that's related to just the healthcare systems being different, maybe different, attitudes towards certain things that can skew things. Now, with all that being said, there are some times where you can adapt tools that are built for one market to another, right? So if you were to build something in the US, you can oftentimes use it if you don't have anything Canadian, but that can also come with just a lot of additional work to understand where differences might arise, right? So as an example, you might say, okay, I trained this model on a US population, and this is what the educational attainment and income distribution look like. This is really like the distribution of the variables that are used in the model. And then we have a Canadian data set. We've never had historical data to train it, but this is what we estimate the demographics of that are going to be. And you can use that to attempt to quantify sort of the worsening of the model or the drift of the model, right? And I mean, it's not preferable, but it's sometimes okay, right? Depending on the context. But yeah. Someone said we use Databricks too. Who's we? Is that like is it part of the curriculum or just your outside of the class, the Databricks? Oh, I guess I'll move on to the next question. How do you keep up with new technologies? Any professional development strategies like following would like to share? That's a very good question. I can give my 2 cents on this. It's going to vary from person to person. So I think it's good to just go to conferences sometimes or read up online of just different things people are doing. I think particularly as they relate to whatever subfield of data science you happen to be in. I also focus on a lot of professional. I can't remember the focus there. I also focus on a lot of professional development related to the industry I'm in. So some of that is just data science and analytics tools and how they apply and how different people are doing different things. But it's also just business areas we're focusing on. We do a lot of work in accelerated underwriting, but there's different areas in insurance and different use cases that kind of come about. And so I like to stay relevant there and understand where people's heads are at in terms of those things. I think like professional development as well. It also involves like on the job stuff. So like I make an effort to find out what other people on the team that I don't necessarily work with are working on sometimes, and just understand what's going on with them. And then also make an effort to take on new projects that wouldn't necessarily be things that I've worked on in the past or might involve me taking on or learning new skill sets, right? So I can give an example that like recently I'm doing a project that's more, we say medically involved. So I'm essentially doing quasi-medical research. So it involves working with our chief medical director. I'm looking at a lot of papers online about medical research and like drug efficacy and potentially going to a conference next week to talk to people around that. And it's an area where it's very similar. There's a lot of analysis involved, but it's not an area that I've directly worked in. There's a lot of considerations around how the data is structured, how to set things up that I've worked with in the past. And so kind of seeking that out and then taking all the skills required for that, I think is a good way to develop as well. And then, yeah, I think it's always going to depend on your specific circumstance, right? So I guess some roles you might have less flexibility. So you have to kind of take on more of a self-learning type approach where you externally learn, right? Versus others where you might get more on the job. I think it's always good to upskill and things so as well, right? So doing courses like that, doing courses like this, picking up different skills, I think it's always useful. Does your company issue financial instruments like cat bonds or other tradable securities to transfer and manage extreme event risk? I'm surprised somebody here knows what a cat bond is. That's interesting. So I guess for the people on the call, catastrophe bond is a piece of debt. Essentially, it's a bond, and it's tied to a catastrophe happening. So it's a very high risk instrument that has a very high return, assuming there's no catastrophe. And if there is, then it doesn't pay out essentially. So you might, it might be $1,000, whatever, for bond. It might have a really good yield, but then, it's a very high risk instrument. So it's not like a government bond or like a AAA corporate bond where it's lower risk. It's meant to be like a high risk thing to diversify portfolios. I actually don't know if Munich Re does cat bonds. That's typically more of a property and casualty type of instrument. I think people have contemplated building versions of that for like pandemic risk on the life side or something, but I don't think it's ever, I could be wrong, but I don't think it's ever been done. So it's something that's more on the P&C side. I don't know if we do it directly. I know a lot of companies and reinsurers will, but I'm surprised that somebody's heard of cat bonds. Yeah, interesting. And then tradable securities. So I mean, I know that's another idea people have had of more packaging life insurance policy. I mean, reinsurance is sort of a way to do that. It's a way to transfer risk, but it's more of a business to business large transaction method. There is facultative reinsurance that's on a case by case basis. There aren't really packageable securities that are traded over an exchange or anything. I know people have talked about standardizing blocks of business and collateralizing and stuff. It's never really come about. It's an interesting idea, but on the life side, it's not really in effect right now. How do reinsurers cover for black swan events? Yes, there's different types of coverage, right? So you can have like sort of stop loss or excess on like very high amounts, right? So one way you think about that is like it could be that you have a block of business that every year brings in $100 million, and on average you pay out 80 million in claims, and you might expect some volatility there. So one year it actually goes to 120, and then another year it's 75, and whatever else. But in general, you have sort of your error bars around it of the 95% confidence intervals between 130 and 60 million in claims a year. You could enter into a reinsurance contract where if it were to ever exceed 140 million a year, all the excess would be paid by a reinsurance company. And then you pay a small premium for that coverage type of thing. That's like one way you could sort of approach that type of thing. Or it could be like in a specific case by case basis. So a specific risk could be reinsured where pandemic happens, this kind of thing is covered. I know, like for example, more specific event coverage we have is like there's cyber insurance now. So in the event that there's ever like a ransom attack on a company, you can get covered for that. And I would say it's not quite a black swan event, but it's still an exceedingly rare thing, right? You might think of a handful of companies get hit really badly a year on that type of thing. So, but it is an insurance coverage that is offered nowadays. I know. Okay, I guess I didn't read the second part, but if you're asking how do you price for them because they're so rare, that's a very good point. So with things like life insurance or other insurance, you typically take the approach of what's called experience-based pricing. And so you have on the life side, for example, what's mortality experience, and that's you have over a period of time, the number of people that have died, and you can use that to make an assessment of the profitability and the risk of that pool of people. But with these more rare events, the really, really, really rare events like a pandemic, becomes exceedingly difficult to actually price them because you don't have any experience, right? You think about the statistics behind it, like there's just not any statistical credibility, right? There's no confidence in what your value is going to be if you've only had a few observations. And so oftentimes you use judgment-based pricing. So like on the cyber side, for example, that you might have people who are IT risk experts who might help to design contracts or determine what kinds of risk factors would increase risk or decrease risk. But there's a lot more judgment, I would say, expert judgment that would be involved in that type of coverage, just because you don't have the experience. We have parametric cap on sponsors. I'll read this article after Artemis. Yeah. It sounds that joke about ordering pizza on Alexa is really true. Is that about what is that? Sorry, is that just saying that your phone can like hear what you're saying, or?
Yes, actually, it was a joke that the person wanted to order kind of a pepperoni with extra cheese pizza, and the Alexa started recommending that can I the more healthy ones, and he got mad. He's like, well, no, you are your cholesterol level is high. Say, I'm taking medication. Say, well,
oh, I see. Yeah, so that's
not refill your medication. And the guy said, I'm going to Canada, and he said, well, your passport is expired. So
that's funny. Yeah, so I mean, I'll say like, I have heard that, and I've had similar experiences where I have a conversation with somebody, and then all of a sudden I get a recommendation about the thing. But then on the insurance side, so there are a lot of tools about that we use to better people's health, right? So make health recommendations, things like that, or different tests that you can roll out to help try to improve mortality. An example of one we do in the US is called the GRAIL test, and like that's a early cancer diagnosis test that we give to people, and it's a blood test where they can detect cancers earlier to try to detect things earlier, treat them earlier, save lives, right? And typically like that's all sort of opt-in by choice though, right? So I don't think insurers are at the place yet where they're partnering with Amazon to do any recommendations. It's typically more like through the insurer they reach out, or they offer these types of wellness products. That's kind of funny, yeah. Someone said, as you mentioned, Canada has a smaller market than the US. On the other hand, do you think Canada has more room to grow in the field of data analytics? That's a good question. We definitely have more room to grow for sure on that life insurance side. Like I think like because we are behind, there's just more. We haven't reached the ceiling yet, right? So definitely a lot of room to grow there. I think there's definitely more room. It's just the question is whether in Canada we can reach the potential, right? I think like one of the difficulties, this is not just an insurance, but this is a Canadian thing in general, is like we are very risk averse people, right? We don't like to rock the boat as much, and sometimes you need to take risks to advance, right? If you don't take risks, then your progress is slow to an extent. So I think Canada definitely has a lot of room to grow, but I think we need to be comfortable with taking some risks, right? It's like the phrase, like you can't make an omelet without breaking a few eggs. So I'd say, yeah, definitely more room, but it's still like the counter to that is need to go for it. Can human insurance risk models be tested on the pet insurance industry as in shorter lifespans in general? That's a very interesting point. So pet insurance, funny enough, that's actually considered, that's more of a health coverage, and it's actually in the US classified as on inland marine insurance in terms of the regulatory thing. So it's considered like property insurance still, even though it's a health coverage, funny enough. It's very interesting though that, yeah, like human health and animal health, there's probably some biomarkers that would be, I'd imagine, similar, right? So in terms of like those, you could maybe say there's parallels, or even processes, there could be parallels, but I'm not familiar with how they underwrite the risk for pet insurance. I'd imagine it's probably less intensive, just with higher premiums to compensate for less precision, right? So instead of like figuring out whether that specific dog, might be at a higher risk, they probably just go, okay, all German shepherds, pay this price, and all, Chihuahuas pay this price or something. That's an interesting thought that you could transfer that over. When insurance companies come to reinsurance companies to manage risk, where do reinsurance companies go to mitigate risk? Another good question. I feel like I get this one, but I've done this before as well. It's a good question. So there's technically no reinsurer for reinsurers exclusively, but reinsurers do get reinsurance as well. It's called a retrocession. So a reinsurer could go to another reinsurance company and say, hey, we want reinsurance on this block that we reinsure, or they could just transfer it all together, right? And so it's called a retrocession. It's like a second layer of reinsurance. And somebody said infinite loop. Maybe yes, you can do 7 or 8 layers of that. It doesn't really happen in practice, but in theory, you can just continually transfer ad infinitum, right? But there's obviously like an administrative burden to doing all that. All the layers of fees eat away at the profit, right? But that does happen, right? So, a company might write some business, the reinsurance company might write some business with an insurer. It's not profitable, and they retro seed that business out, or they change the financial structure of it. So it does happen. Yeah. I'm just reading the comments here at the top of the risk. Who ends up holding the bag? So typically reinsurers. So one of the reasons that people approach reinsurers is we have a lot more capital typically, right? So like one of the big things about insurance is that it's like it can be capital intensive. And so imagine if you're writing a bunch of new business, there's a lot of initial investment, and then you have to, you have a lot of initial investment to take on a policy, and you don't really start to see financial benefit until later on. And so you could approach a reinsurer to handle that, right? It's cost to underwrite a policy to administer is a lot. There's also just the idea that, you might expect a lot of claims, and then, you have to hold what's called a reserve for the claims. And so that's essentially like an amount of capital that you project you will need to cover future claims, kind of discounted to today. And there's rules about how you can use reserves, blah, blah, blah. And sometimes you want to free up some of that to invest in things or do strategic projects or whatever else. And so it's sort of another reason there. And then you can actually, somebody said you can transfer risk to institutional investors. So you can do cat bonds is one way to transfer risk. And then, yes, sometimes you'll have entities that'll be offshot. So a company might be rated, AAA or something. But then you can actually break off certain parts of your books to a side company that's at a lower risk. If you want them to hold more of the risk, it becomes a separate thing. But yeah. What are the typical qualifications of the project managers for your kind of projects? Adding SME degrees, hiring for machine learning engineer, data analysts. Do they hire interns? So a few questions here. So for project managers, I would say different backgrounds. We have one that actually came from like a software development background, and a few that don't really have tech backgrounds, more just general project management. So I think it definitely varies. We do have interns in the summer. We actually our interns just started a couple days ago, I think on Tuesday. So we have one data science, data engineering intern. And then, we are, I think, hiring for one MLE position. And I think the data analyst position is not within our team. So within our company, we have a team of data analysts that work more on the operational side. So they do a lot more of like the database, not administrative, but like operational data work. And so I think that position might be there. But we are hiring for one machine learning engineer right now. Yeah. And then qualifications would be sort of like I was saying before, like the sort of a robust skill set. I would say that touches on both sort of the data science side, so good understanding of like data science practices, principles, techniques, but also like a stronger engineering foundation. So kind of a hybrid skill set, I would say, between like an engineer and like a data scientist. Can we say data scientists do less coding compared to machine learning engineers? Is that a fair assumption? So it depends on what kind of coding, right? And it depends on the specific person. So they do less building of software, but a lot more, so less software development, you could say, but more, experimental or, I don't know what the word to call it, applicable code, applied code, right? So like today, I spent the whole day doing that project I was talking about where, it's sort of doing a medical study. And so I have, thousands of lines of, data processing and model building and different things like that, right? So I would say like data scientists do a lot more of that, whereas a machine learning engineer might do more actually building of software, right? So building out classes and deploying things, whereas you might do a little more experimentation and code related to that as a data scientist. What are the modeling for pricing? It's for new business only. How do you handle repricing with AI models? It's a good question. So a lot of that risk assessment, the underwriting talks about pricing of new business, right? So that's business you don't, or life insurance wouldn't have yet. So for reinsurance, that's sort of different. So typically there's two reinsurance pricing sort of different ball games. So there's two kinds of reinsurance. There's either like in-force or I guess new business as well. So new business might be just their insurance companies rolling out a new product and they want reinsurance on that product and it hasn't actually been issued yet, but it's just, you kind of know it's going to be a term insurance product. And then this is kind of how they underwrite, this is their process. And so the pricing team is their own method and set of tools for doing the pricing. And it might involve some machine learning models, but it could also involve a lot of just traditional actuarial type calculations, right? So one of the things is for that experience, I would say is king, right? So if you have a company's historical profitability, essentially, how many deaths they had, how many claims they paid out, That's typically your number one source of information, right? And then from there, you'd supplement what you don't know with models. So that's typically, number one for doing these types of deals. How are these different data sources integrated these days through API pull or just manual export, CSV? I come from an engineering background, and I've heard lots of industry 4.0 promises of integrating different systems from sensors on the factory floor to ERP systems. The reality often fails due to integration issues. Yes, so that's an interesting thing. So I think like it depends on the industry. Obviously, it depends on what you're dealing with in particular. But I would say we've done a good job of now integrating things by API, but it's all very like simplistic in the sense that it's not overly complex. I'd say in the US, most of the commonly used data sources are all connecting by API, right? So you just hit an endpoint and then you retrieve a data source, and that's become sort of the standard there. But I mean, I think some of the things are that some things are still done. I mean, in a production sense, if you have an application that's used to directly assess risk of API connections, a lot of the way things are done, though, is still through, CSVs, XMLs. There's still a lot of different structures of data sources, transferred by SFTP for projects as well. And then what was the last part of this question? Yeah, scripting was the usual path, which is not effective. We simply want to pull data from Oracle to a SQL-based application. Yeah, one of the other things that's always tough is you have APIs, but then certain things, are stored in a database, and connecting databases can be tough. There's always those challenges, right? In terms of connecting things. And I know, like, even not just on the data science side, but on the IT side, like that's always a challenge, is doing these big system integrations, right? Is having things talk to one another, especially doing things in a way that's secure, right? I think it's a big thing is, you can connect things, but making sure that traffic's always secured and access and things like that are done correctly is always a challenge. But yeah, it's always difficult implementing anything, I think. There's one additional question at the bottom of the chat. Is there any role as a statistician in your team, or is it part of the data scientist typical task? I would say it's part of the data science task. So data science, I think, on our team is the most varied of the roles in the sense that, well, then maybe MLEs I'd say are varied in terms of like, they have the straddle engineering and some of the data science, but then I think data scientists wear a lot of hats as well. So when you're doing very technical work in terms of building models, sometimes deploying things, doing just analysis, oftentimes what I do is sometimes more on the actuarial side. So I have to draw on like an actuarial skill set, do experience studies or things like that. I also do a lot of work in, like I was saying, pitching ideas to people. So either to a client or getting buy-in internally. A lot of that's sort of organizational stuff. So I think data scientists do a lot of that. Framing things up in decks and whatever else, right, is sort of part of that, framing results. And then also a lot of compliance work, I think, as well. So either helping to form policies or working with legal to figure out what we can and cannot do. I'd say a big part of my job as well now, and like a part of some of the data scientist jobs as well. Yeah, we do a lot of the statistics within our job role. I see one question here. How do Munich large language models source their operational data? Is it primarily through API integration through model context protocol? So explain what you mean.
Yeah, so the data which collecting like for the large language model, is it through API integration or is it following any new thing like model context protocol, like the model server and the model clients?
Yeah, I think we do have some just endpoints set up internally for our internal LLMs. I mean, I think that's an area I'm a little less involved in, but it is an area I think where we probably are a little more cautious. So there aren't really as many uses for LLMs, I would say, within the life insurance space right now. So a lot of it's just kind of experimental. So I don't know if there's any like large scale implementations as of late. Yeah. I do know on the P&C side, because I have a friend who works for a property and casualty insurer in Canada. They are a lot more quick to adopt LLMs for a variety of use cases. We're just, because we're more risk averse, we don't fully trust, I'd say, the outputs in the sense of, the hallucinations. There's not as much interpretability into some of the machinations in the background that we're a little more cautious about the scope of use, right? Yeah.
Okay. Thank you.
Is there any other questions? If not, then Kaylee, should we have like a quick break, like a 5-minute break, or?
Yeah, that's perfect. Yeah, we can reconvene in 5 minutes. So what, 53 past the hour?
Awesome.
Okay, great. Okay. Yeah, Tristan, whenever you're ready, feel free.
Perfect. Everyone can still see my screen, right?
Yep.
Cool. Yeah, so I guess now I'll go to the case study part of the presentation. So the one I'm going to talk about now is building a mortality model for group insurance. So what I focused on for really the first part of the conversation, or the presentation rather, when talking about insurance and underwriting, has been focused on individual insurance. So this is really insurance that individuals would purchase. So you can think of that as being a policy that would apply just to you, that you go out and buy. In this case, we're talking about group life coverage, and what that means is that these are life insurance coverages that would be through typically an employer or an association. So some of you might have this experience. If you work at a company, join the company, you'll get a benefits enrollment, and in that benefits enrollment, you'll have health insurance, dental, and then you'll have this life insurance coverage. Oftentimes, it's kind of just built in. And it might be for a certain multiple of a salary, like a one-time or two-time per year salary that's covered through an employer, and that would be considered group coverage. And so this is really building a mortality model that focuses more on that side of things because it is a different insurance market, and things are looked at a little differently for a few reasons. So here I'm just going to kind of talk through a little bit about the specifics there. So it's purchased, and sold at a group level, as I said, through an employer, or it could be through a trade union, something of that nature. And so the difference between that and individual life insurance is that, with individual coverages, you have data on an individual and you can use that to price for an individual, whereas group life insurance is priced at the group level, and you typically don't know anything or even really assess the risk of individuals. It's all done really in aggregate, and historically has just looked at a set of very basic factors because you could not do any underwriting on the individuals. So in the example I was giving earlier, you'd have a benefits enrollment. At a company of 1,000 people, you'd have 1,000 individuals who are covered under this one large group life policy, or one large group life coverage with 1,000 policies within it. Now, you wouldn't know anything about any of those 1,000 individuals, but what they would do is they would look at properties of that entire group and try to use that to ascertain what the mortality or the risk of that would be, essentially, right? And so historically, with limited data, what that means is looking at things like just at a basic level with the gender mixes, looking at what the age mixes, right? Because we know age and gender are some of the biggest differentiators or segmenters of mortality. And then the other one that was typically used was either industry or work type. So there might be assumptions about certain industries over others having higher work or lower mortality. So as an example, of the company where Alaskan crab fishermen, I remember that being a show back in the day. The company were Alaskan crab fishermen, the risk might be a lot higher than if they're school teachers, right? And so that's sort of one of the factors they would use to price this block of insurance is, what the age is, what the gender mix is, and then also what kind of industry it's in, because that can oftentimes dictate what the mortality is. There's a few other factors as well. The size of the company can impact things as well. There's more volatility and whatnot, but typically very rudimentary sort of coverage there. And then I think they can, on the group side, as opposed to the individual side, they can kind of approach it in more of an adjustable way where in future years you can renew and change rates depending on experience. But typically when, doing the underwriting, because of the lack of data, there was just not a lot of complexity there. But, as I said, on the individual life side, in more recent years, we are seeing a lot more data available and more sources of data that aren't required to be collected, right? So one of the reasons that there is no data on individuals on the group side is not because you don't know their names or who they are, but because you weren't going to, as part of a benefits enrollment, ask someone to go to a lab and get value. It's sort of a covered quantity. You just want to kind of price it at the group level. And so we can't actually get information about people through data sources. Just we can't administer these taxing labs and things. But in the modern world, we do have access to these data sources. And so the question is really, how can we then take these data sources and leverage them to improve how we price group insurance? And so one of the things I want to talk about here, even prior to starting a project of this sort, is some of the things I've touched on before, which are the legal and bias considerations. And so I think, what's important before undertaking any project like this, especially I think in a highly regulated industry like life insurance, and one that leverages a lot of very sensitive data, you should ask yourself about legal and bias considerations before even starting a project, right? So first and foremost is, do you have consent to use this data? Are you legally allowed to do this, right? It seems like sort of a simple question, but I think oftentimes people don't always stop and actually think about whether they do. And then the other aspect of that is, will you have issues with consent going forward, right? So you may have, for example, a data set that you could use to build a model, and that data could help you, to predict rates for group insurance. But if you don't have access to that data on a go-forward basis, say you have just one sample of group life insurance policies where you have personal identifiers, but then going forward you never have them, that would prohibit you from actually implementing a solution. And so that's always a consideration as well. And maybe you do have the data on those people, but you wouldn't have consent for the data going forward. That can also be a practical problem to building something that can actually deploy it, right? So always something to kind of consider is, don't build things in isolation. Consider what the end goal of it is, what the end implementation should look like, and then factor that into the process of actually building out the tool or the model that you're looking at. Another one is there bias in the data? So this doesn't just mean implicit bias in terms of, is the model going to ultimately bias against a certain group of people, but are there any biases in the way it was collected or in just the distributions that you see of the variables, right? Was this collected in a weird way? Was this scraped somewhere from a data source that's not going to be representative of a true population it would be applied to? Those are things you should always ask yourself, understand where the data came from, what it looks like. Is there anything that stands out in terms of its integrity or sourcing that you should be wary of? It could also be that doing some sort of EDA, you find that there's a missing rate of 50% in some key column, and that missing rate is heavily biased towards a certain group, and you don't necessarily know that that's going to impact downstream results, but then obviously that's a sign that it could, right? So just kind of understanding data, issues with the data, biases in the way it was collected, and then any considerations there. And it doesn't necessarily mean you have to stop what you're doing, but it's always things you should be cognizant of, I think, when going into a problem. I think that's one thing from my perspective that's really important in data science, is just really understanding the data and how it's structured, where it came from, and all those types of things. The other one is, could this data result in any ethical or PR issues? An example of this could be, not in this context, but if we were to use, say, instead of a non-traditional data source, we were to use face scans to price group insurance. Now, obviously, there's a lot of susceptibility there for bias, right? If you're using people's appearance, for example. And so that might be, it's a kind of out there example, but that could be an example of a data source or project where, although there might be some effectiveness if you were to actually go about doing it, on the ethical or PR side, there's susceptibility for bias, or it just kind of gives you an icky feel. And might be a sign that you shouldn't proceed, or that you should change course and adapt. And then regulatory constraints. I have in this example, this is data FCRA compliant. So FCRA stands for the Fair Credit Reporting Act. One of the things that's interesting about underwriting is that in order to use certain data sources, they have to be compliant with this law, and that involves things like notifying people of adverse decisions, meeting certain standards. So if you're ever going to use something in underwriting and production, and it's going to make adverse decisions, you have to make sure that it's compliant with this set of rules and regulations, right? So that's something to always consider as well. And there's different variations of things like that, but just be cognizant of the legal environment that you're in and any potential pitfalls there. The other one I have is, there any regulatory issues or increased regulatory burden? So that's kind of on the topic of what I was touching on before in relation to credit data. So historically, credit data was something that was used semi-frequently within life insurance underwriting. And more recently, we've seen a regulatory shift. And so people have started removing that from their processes, from their models and things of that nature. And so it's always something to be cognizant of, is your idea future-proof? Is this something that you could potentially see there being an issue with down the line. And if that's the case, even though it might be perfectly fine right now, you might want to take another approach. These are some of the non-technical considerations, I would say, but there's also technical components to all these things as well, right? That kind of influence the data you use and how you kind of construct your project. In the context of group insurance, in this example, I would say, do we have consent to use the data? Yes. Will we have issues with consent using this data going forward? In this case, we might use some de-identified data at a group level. So no. Is there bias in the data? In this case, we haven't really defined the sample we're using, but we can suppose that we have a very representative sample of the group insurance market. The data has been collected, it's robust. There's no obvious biases in how it was collected or in the quality of the data. It's fine. And we see no ethical issues with the use, and so we're probably okay to proceed. And the other one, before starting would be, understanding the problem, right? So I think you should always think deeply about what problem you're trying to solve, what you're actually targeting, how should you judge, success, right? So that means, understanding the proper metrics to use, number one, right? From the technical side is, is accuracy the right metric? One example in our case that you will see in the next slide is we use within life insurance these kind of interesting decile charts, and that's like a visual way to just show segmentation across different score buckets. I don't really see it in other industries, but it's a very life insurance specific metric that's used to quantify mortality segmentation in our models. And so it's understanding what metric you should be using and then what you would understand as being a successful build, right? So as a certain example, do you want to target a certain precision? You're targeting a certain indicator, or is there a certain level of overall accuracy, or should you be using F1 because you want some balance, right? There's different considerations there that you should think of. And then also, even before that, what are you actually targeting, right? So oftentimes you think of like prediction or regression problems very simply of I just have to build a model that predicts 1 or 0 or, regresses on this continuous variable, right? But oftentimes, there's ways, slight nuances to how you can actually set these things up that make a big difference, right? So with mortality, for example, one of the things with insurance is, you might want to target deaths directly, right? And that might seem like the right approach, but, in fact, typically with insurance, you don't model mortality or deaths directly. You model them on top of an underlying expectation, right? So within the life insurance industry, there's something called a mortality table, and that typically varies by, say, 3 things, right? So age, gender, smoking status. And really what that means is that everything is all relative to what you'd expect from an average person of that age, of that gender, of that smoking status, right? So I'm a 29-year-old male who is a non-smoker, and so I might have an expected mortality of 0.001, whereas my father is a 65-year-old male smoker who might have a mortality rate that's 10 times or 15 times what mine is. And so if you were to build a model and model mortality directly, you capture a lot of that variance, just comes as a result of age. And so it's always useful to understand what you're actually trying to model, right? All insurance is really priced relative to those underlying expectations. So that's just an example on the individual life side of a consideration about how you're actually setting up your modeling. You might just think, okay, modeling mortality, but it's actually modeling something slightly different, right? And that'll give you better, more impactful results. And I think oftentimes that comes about through, conversations with whatever stakeholders or business individuals you're working with on these types of projects to really understand what they're looking for and how they would approach these types of problems. And then here I talk about doing an EDA as well. So, I think a robust EDA is always something that needs to be done before a project, and you should focus on a whole bunch of things, right? So really understanding the data, profiling the data, understanding what it looks like, how applicable it's going to be to your use case, trying to understand biases and issues, like I said. So I think that's a big one, is understanding if there are any issues, and if those issues are distributed in a way that's going to cause problems, and then any peculiarities around certain things, right? You're going to have to deal with this column in a certain way. Do you have to do any additional feature engineering or processing that you can anticipate, things of that nature, and then also understanding how the data relates to what you're trying to model, right? So, for example, if you were to use the data and use it within like a GLM, you might have an independence assumption. So you might see that variables are correlated, and you have to deal with that, right? So I think it's important to really understand the data, understand how it relates to itself and how it relates to your ultimate goal. And so, in this case, it involved looking at a pool of group life data, really understanding how it ties into mortality, and how the third-party data appended to that would tie to the ultimate outcome of predicting mortality. So, here I've taken this chart from the white paper that kind of shows this project and this model, but this is really showing that decile chart I was talking about. This is actually post training of the model, essentially. I'll explain the chart and then I'll kind of get into what this means more or less. So this is A to E by size and risk score band, right? So on your x-axis, you have risk band, and this is from the model. So each of these is essentially a band from the model for the company that predicts what the mortality is going to be. And then on the y-axis, you have what is called an A to E. And so in insurance terms, this is actual to expected mortality, and it's a ratio, right? So it's saying you have a really naive expectation of what things should be, and that's just based on age and gender, whatever else, right? So just a few high-level profiling variables. And just based on the mix of people, this is what you would expect the average mortality to be. And when we look at mortality in terms of how we model it, we look at how well it segments beyond that. So you show an actual to expected. And so essentially in this case, if you're looking at that risk band 5, that is probably the highest predicted mortality group. And we see, in fact, that those companies have 1.5 or slightly less times higher mortality than would be expected if we just use like age and gender. And so really what that means is that the model is segmenting those higher risk companies better than it would be if you were just to use a naive definition like we discussed before that uses just age, gender, and say company size, right? Here they split it out by size of company, just to show that slight differences in segmentation. Really, this is just the way that we would approach sort of quantifying the performance of the model, right? And so in this case, you might use either boosted tree maybe or GLM, and again, it's going to vary based on the use case, right? So if this were to be used in a highly regulated way to price, you might prefer using a GLM just because it's more interpretable. It's easier for regulators to kind of look at and work with. But if this were something that there's a little less scrutiny on, you might say, okay, we want better performance that comes to the tree-based model. And so you might choose a different algorithm, right? And so it's always important to understand the choice of model and how it relates to your ultimate goals. You might, try a few different techniques out and find that one is better, but for other reasons, it might not fit your use case. Also, complexity of deployment is another consideration in this respect. So one of the things you have to be cognizant of is, ultimately, how will this be used, right? And so you might have some sort of deep learning model that actually has the best performance, but if it is costly to deploy and maintain, and there's a lot of technical overhead to use, then it probably doesn't make sense if there's only marginal improvement over simpler technique. I'm not saying that simpler techniques are always better, right? Because I would say they're not, but things should always fit the use case. And so, yeah, in this case, I think they tried both GLMs and then slightly more complex tree-based methods as well. The other one I want to touch on here is the concept of bias testing. So with this model, they built a model that's able to segment mortality within the group insurance space. And so, building on just those very basic assumptions that were used in the past, they can now further their ability with this model to segment mortality, to identify higher and lower risk blocks of business. And that allows for more precise pricing. But it's still important to understand that, while the predictive power might be very solid from this tool, you want to ensure that it's a fair and unbiased model, right? So that involves doing bias testing in the process of actually training these models. So you're not deploying something and then finding out down the line that, oh, I spent all this time building it, we're ready to deploy. Oh, it's actually, there's a big issue with how it's built, and we have to go back to the drawing board and correct some things. So it's always good to do that as you're going. Incorporate robust bias testing into your training routine and understand how it's going to impact the final results. And then here I talk about deployment, right? So I think one of the other considerations I said is that's really important is through the process of actually building these things, even from the very beginning, ultimately having the deployment in mind, because that can influence some of the decisions you make along the way. So this is really the flow of how it would be implemented in production from the viewpoint of that paper there. So you'd have individual level information, you'd have de-identified medical information that would be appended together in a de-identified basis, run through a mortality model, and then it allows you to get like that segmentation that we see above, which allows you to improve your pricing of these blocks of group insurance policies. But now thinking about how that would be implemented, if this were being used on the side of an insurance carrier, you have to understand how it would fit whatever existing process they might have, right? So if they have a legacy system or they don't have any system at all, it's going to vary how you would actually approach deployment, right? So if you know that it's going to be a legacy system, you might want to approach it one way. If you know that it's in something more modern, maybe you're going to deploy by API. If you know that it's going to be something that is higher latency, you might have one consideration or another. So I think it's important to kind of understand that and understand as well who's ultimately going to be using it and what cadence and things like that. Another consideration in terms of deployment is how it will be interpreted, I think, as well, and how the output is sort of structured, right? So like in this case, for example, on the very right, we have sort of the output there. We have low, medium, high, higher risk, right? Like in reality, you could have some continuous score or some continuous prediction of what the mortality is going to be, and that might be more useful for somebody who's actually doing the pricing, right? So they can actually take that number and implement it. Whereas another use case, it could be that a number is not as useful. Maybe the end user is not as technically savvy, and a number is actually more information that's needed. So you might have to sit there, figure out what sort of segmentation makes sense to bin your predictions, and then delivering something like low, medium, high, although it's less information, might actually be more palatable to whoever's sort of using it to make a decision, right? And then I guess additional to that is the interpretability aspect. So people might get these outputs and then might wonder, okay, why am I getting this output? For some cases, if you're implementing a model that doesn't really have a human user, interpretability might not be as pressing of a consideration if it's built in sort of a more automated technical process. But if there's somebody in the end of it that has to make a decision using it, and especially if they want comfort in the prediction a model is making, they might understand why. And so that would involve making sure that whatever interpretability you're using, either coefficients on a simpler model or something like a SHAP value on a more complex model, making sure that that's available and that's structured in a way that whoever's using the model can actually understand, right? So as an example here, you might have this medical information that goes into it, and what could be driving it at an aggregate level is increased incidence of cardiovascular disease in one company. And so, somebody who's sitting there pricing a group insurance block might get the high risk, and they might want to understand why, just for their own comfort, because on that side of it, they have to take this price and then go to somebody and say, hey, we have to charge you more money, right? And obviously, there's a benefit to that in terms of making more money, but it could be a tougher sell potentially. And so understanding why maybe on their end can be important. So those are some considerations, I think, for actually building these things out, is understanding what might need to be done in terms of deploying and implementing them. And then here I have post-deployment considerations. And so, typically, I think we sometimes think, you build a model, it gets deployed, that's sort of it, you're done. But I think, the whole life cycle of a machine learning model is more than that. So you have the deployment, but then you have things like monitoring and updating, right? So I think monitoring is one piece that is always important to think about too, in terms of building it. And monitoring can involve both, monitoring the distribution of inputs into the model, right? So seeing, is that drifting, right? As for example, if you were to deploy this group insurance model, is the socioeconomic status of the companies shifting a lot? Does that make the model less applicable to this new mix of companies? That's one consideration. And then also looking at, how the outputs are changing, right? So are the input data is the input data looking more or less similar, but maybe there's some deeper statistical differences that are manifesting in differences in score behavior, right? That's something to monitor as well, right? And so it's always important to monitor inputs, outputs, understand our models performing well, and then understand, when it's necessary to go in and either, retrain or replace a specific model, right? And drift is something that's always going to happen. It's just, how do you measure it? How do you action it and decision off of it? And I think, this ML ops has become definitely a hot area in terms of how you look at those things. But definitely an important consideration when going through the exercise of building a model is, making sure that there's always a plan in place to understand how things are drifting. And then I think even going back to the training side of it, understanding, what needs to be in place on the training side to make sure that if you do need to rebuild, it's very seamless, right? I think, one of the things is you can build something in a very one-off fashion, but you need to retrain it, then it becomes a pain to change things. I think sometimes setting up code and processes in a way that is scalable and repeatable can help, make that a more seamless process. So I guess this is sort of the end of the case study through or for pricing of group insurance. So open the floor now to questions. I think I see a few in the chat as well. You see. So what do you mean by PR issues? Could you please explain? Oh yeah, public relations. It's okay. Yeah. So yeah, that's mean public relations. I think it's always a consideration with doing things in any business is, especially if it's customer impacting, is if this were to be published in a newspaper, would you feel comfortable with the public seeing this, right? I think it's always a question you should ask yourself. And if the answer is no, then probably something you should, potentially avoid doing. The annual group policy price is going to be affected by the data that's collected from employees' claims throughout the year. How do you monitor models? So I'll answer the first question there. So is the price going to be affected by the data that's collected throughout the year? So good question. So I think this exercise is mostly targeted on for new business. So it's building a model when you don't have any experience on the block of business and understanding how can you adjust the price there. So it's a new company, maybe you've never had insurance with, or a new company that's never had insurance policies that you're covering. And so you're understanding what the risk is going to be like for that company. I think if you were to get experience as time went on, you'd use that over any sort of model prediction. But it's one of those things where even at scale, I would say, even if it's a large enough company, there aren't that many deaths typically. And so it does take a long time for you to get a sense of how the risk is, right? On something like an employer, medical or dental coverage, I think you typically get a better sense of what the risk is there, essentially what the utilization, you would call it in that respect, is. Just because, people go to the dentist a lot of time, you have a sense over a large enough pool of people within a year's time frame about how much they're going to spend on dental care and drugs and things like that, that you can make adjustments to the price. But I think still on the life side, it still would take a matter of years. So especially on a smaller company. And so it still would be useful to leverage a model initially. And then if you did see divergence as experience built, to adjust from there. But yeah, you definitely could vary it based on experience that came in. And then how do you monitor models to identify drifts? So I think, yeah, you can do it on either a manual way or like a more automated way, but I think really the two biggest pieces are monitoring inputs and outputs, right? So you have say 20 features or variables that are going into a model. Are their distributions the same or are they vary, right? So was a model trained on a distribution of ages where most people were kind of in the 30 to 50 range, and then you had a good normal distribution, then all of a sudden you're seeing that distribution of ages is like shifting down where it's heavily skewed towards 20-year-olds, right? That's something to monitor because the population you train it on, the population you deploy it on, if they start to vary a lot, you're going to have degrading performance typically. And then the outputs is also one way to look at it. So even just high level distribution of scores, how they vary by key dimensions. And then also if there's a business metric that you build off of the score, if that is degrading as well, right? So in this example, it's tougher because it's mortality, but you could have, for example, like I talked about earlier, a misrepresentation model that looks at targeting people who are likely to lie about smoking, right? And so you might have that model deployed. You would implement it, monitor the inputs, but you monitor not just the distribution of scores, but say you had it so that everybody with a score above a certain point was sent to get labs collected. You might actually monitor the rate of misrepresentation that was actually found when they got those fluids collected. So it might kick out 5% of people, and that could be stable over time, but you might see that proportion that were actually lying about smoking is decreasing over time because the model is out of touch with what is actually happening, right? The indicators for likely to lie may have changed over time, and now the model is just out of date, right? So I think like monitoring a business metric is honestly probably the gold standard, but in cases where it's not always available, then it's always good to rely on inputs and outputs more generally. Are these models made in a team and then combined together and tested entirely at the end, or is it generally assigned to one or two individuals? Is that like a question about how you go about building a model in like Munich Re, like our team?
Yeah, basically.
Yeah. So good question. Yeah. So I think it varies based on the complexity of the model. So some of the more simpler models, it might be one person that primarily would do the heavy lifting to actually build it. Typically our process is though for any model, we would have a team of 3 people. It'd be one person building it and then 2 reviewers who are tasked with, I think, both reviewing a technical soundness of what was done, but also reviewing the assumptions and thoughts that went into some of the decisions. But then we have some really, let's say, complex models that, for example, leverage medical history. And so you're looking at billions of records, a lot of really complex data, and the act of actually building that, the feature engineering, the pre-processing, the EDA is very technically complex and a lot of work. And so that might involve a team of 5 people, right? You need one person looking at this type of medical information, this person looking at that type of medical information, trying to understand the best way to structure things, one person trying to understand longitudinal, that there's many different aspects to like a very complex model that would involve like a very large team. And so like in that respect, you might have like more people. So it does vary a little bit.
Okay, thank you.
How do you assess or price risks like extreme event risks that don't have enough historical data? Yeah, so I mean that's one of the difficulties in life insurance is that even just death in general is not that common, especially within younger ages, right? Where people typically have insurance. So you typically have to wait for credibility to build. One of the difficulties with life insurance too is that you might have policies written 20 years ago, and then 20 years passes and you now have an understanding of how things relate to mortality, right? Piece of information. But then the medical system has changed in the meantime. You've had a pandemic that's influenced mortality. You've had all these variables that influence the cohort you're looking at. And so then that's something you then take into account as well. So you sometimes get those issues. When it comes to really rare events like the black swan type events, pandemics, things of that nature, oftentimes you just can't take the experience-based pricing approach and you have to use judgment-based pricing, right? So you have to get people together who understand the nature of the risk and what factors might influence it. And then they have to sort of set a price based on a few different things. Right? So obviously you're going to have your expenses, target profit, and they have to determine what the actual risk level is, and then level set that with, you know, the entire block you expect to write, right? So for something like that, you know, you might expect a certain amount of volume. There's going to be volatility implications there, so you'd have to just factor that into the financial aspect of the pricing, but it's oftentimes just based on more judgment. You won't know what percentage of coverages are actually going to have a claim. You might know it's going to be 1 in a million, roughly, but you don't know exactly where it's going to be, and you know, you have to just use it, the expert judgment to the best of your ability. Yeah, it's tough.
Hey, Tristan, I know that it's up to 1:30. So maybe if it's okay with you, is this a good time to kind of wrap up?
Yeah, for sure. Yeah, I guess thanks to everyone, and everyone can feel free to add me on LinkedIn as well if you want to keep in touch and connect. Yeah.
Great. And I know in the past we've shared the slides. Is that still a possible? Okay,
Definitely, yeah.
great. Then I will post that in the Slack channel for folks to take a look at. Thank you so much. That was a great session.
Thank you. All right. Thank you, everyone. Thank you.